Graduate here. All right, let me ask you, Jenna, is it okay if we record this presentation?
Yeah, that's great.
Wonderful, because it will be archived, it will be turned into a YouTube channel, a YouTube recording, and then future students can watch your presentation and learn from you. So you will have a larger audience than what appears. We're broadcasting from Eisenberg Classroom Building right now, room 111. And I'm counting about 11 of us in the room here, and then numerous faculty and other people at their remote offices. And then in the future, people will be able to watch your YouTube presentation. So Jenna graduated with a degree in environmental geosciences a handful of years back, and became very interested in air pollution meteorology. I don't doubt at all, under the mentorship of Dr. Julie Snow. And I chatted with Julie this morning, and I want to convey, Jenna, that she's mighty proud of you. Then Jenna went on to North Texas and began her research in the realm of how urban forests help to enhance air quality, and vice versa, how forests are affected by air quality. And currently, Jenna is working on her Ph.D. in Boston. So we're very proud of you, and we're wishing you luck in an expedient progress through a doctoral candidacy, which many of us understand is an incredibly challenging proposition. So we're proud of you. And I just want to confirm, you have an MSc, you have a master's degree in the science, is that correct?
Yes, that's correct.
All right, wonderful. I know that the MSc is a very valuable credential, and we constantly encourage our students to pursue that. So with no further ado, Jenna, please tell us what you're working on.
Wonderful. Thank you so much, Dr. B. Thank you all so much for having me today. I'm really excited to be here. Wish I could be there with you in person, but I actually have to go teach after this, so just not a possibility. But I'm really excited to talk to you about my research experience in urban forest interactions with air pollution. I am also part of a program here at BU called the Urban Program, and we specifically focus our research in urban areas in order to solve urban environmental issues. So if that's something that you or your students have questions about in the future, I'm more than happy to talk with them. And you can see that this is a photo of me with my dog in one of my urban forested areas. So let's get started. We are going to do a little bit of a step back first and just talk about the basics of air pollution really quickly. So what is air pollution? What is the idea behind it? Air pollution is any sort of substance that enters our atmosphere, and it can be particularly harmful for human health, the health of any living organism on the planet, and it can also damage other components of the environment, such as waterways. Pollution can come from many different sources. I have a couple up here right now, but of course there are many more. One component is electrical power plants, which does produce a lot of different types of pollution, including carbon dioxide in the emissions. And as we know, carbon dioxide is a greenhouse gas, so it does warm the atmosphere. Agriculture can also pollute the environment, especially with the use of synthetic fertilizers, which produces a lot of nitrogens that enter the atmosphere. And of course, the livestock industry as well. And along with nitrogen entering the atmosphere, that nitrogen can chemically change and eventually form other gases such as ozone. And then of course, we have the transportation sector, which we know can produce, again, many different forms of pollutants, including a pollutant called particulate matter, which instead of a gas is actual particles in the atmosphere. Those are from any form of biomass burning, so it can also come from wildfires like what's happening out in California right now, but also from fossil fuel combustion. And this increase of pollution into the atmosphere in general can cause a lot of environmental concerns. We know this, we know that, of course, We can see warming in the environment from different greenhouse gases. We can also see a lot of warming in the environment from components of particulate matter like black carbon, which warms the atmosphere around it. So not only do we see a lot of environmental concerns due to air pollution, but we also see a lot of human health issues as well, especially when we talk about a pollutant like particulate matter. So you can see a little photo of PM particulate matter here. These ones are black carbon, which are smaller, about smaller than 2.5 microns in diameter. So if you just pull like a piece of your hair, they are actually smaller than the diameter of a piece of your hair. And the issue is that when we breathe those in, they can cause a lot of lung issues, and they can also cause cardiovascular issues as well, because those particles are so small, they can actually enter the bloodstream. So you're looking at heart disease, asthma, COPD, and we get an influx of those in areas where we have more pollution. We also see issues with other forms of pollution like ground level ozone, similar symptoms, shortness of breath, wheezing, coughing, fatigue, and then we see these conditions worsening, particularly with asthma and COPD. So we are concerned about air pollution, not only for environmental reasons, but also for human health reasons. Now, the connection there is that this is especially important in urban areas, which is where I study. And the reason is because urban areas have a continuous buildup of infrastructure. Now you're seeing trees right next to a roadway here, and this roadway is continuously putting pollutants into the atmosphere because of the cars and trucks that drive down it. When we increase pollution in urban areas, you're going to see environmental issues such as the increase or the decrease in visibility. And so it makes it harder for people to travel, harder for people to get around. And then you're also going to see negative health issues as well. So the increase of pollution into the atmosphere is going to cause increases in prevalence of asthma conditions and other conditions that relate to it. And where you have a lot of pollution and you have a lot of people, that combination is just not going to be good. So how can we mitigate or remove the air pollution in specifically urban areas where you have a lot of people and a lot of pollution? One connector between all of these photos is the use of vegetation or trees. And that's what I'm particularly interested in, is how trees can act as a natural air filter for different forms of pollution. So how do these trees remove pollution from the air? Well, there's a few different mechanics, and we're looking at the components of wet deposition versus dry deposition. And what that means is over here on the west side where you have wet deposition, that can include any form of rain or snow, any precipitation can envelop those particles of pollution in the atmosphere and actually deposit them onto the tree and down through the tree to the surface. And then particles can actually also just deposit onto leaves of trees as well, and actually embed into the waxes of those leaves, and then fall to the ground when the leaves fall later in the year. If you're looking at this in action, you'll see some of my students here when I worked in Texas. They are using a particulate matter monitoring system. And you can see that this bus is driving past, and that bus is actually emitting pollutants, especially in this case, particulate matter, into the atmosphere. That particulate matter then comes down from the atmosphere and deposits onto these trees over here. And these students are actually measuring how much particulate matter is in the atmosphere when a vehicle drives past versus when there are no vehicles on the road. And then they also measured in vegetated areas as well. So this monitor is one way that we can engage students in understanding how trees can remove pollution from the air, and how pollution levels change depending on where they are location-wise. So that location comes into play, especially when we're talking about urban areas. Locations in urban areas, high pollution areas such as roadways, intersections, places like that. It is also very important to note that the research shows that different species of trees remove pollution in different quantities. So you're looking at some oak trees here, and this is also an oak tree. These types of trees are going to remove that particulate matter from the air in different amounts and at different rates than maybe a maple tree or something like that. So that's some research that people are starting to investigate more and more, which is very important when we're looking at what trees to plant in urban locations. So the way we are measuring pollution in the atmosphere, we have, my lab here at Boston University has a few different samplers for a few different forms of pollution. So the goal of my research in my current system is to understand how pollution moves through forests that are fragmented, especially urban fragmented forests. And what that means is these forests can be cut right down the middle for roadways. It could be cut for, in this case, an open field, any power lines that need to be placed, something like that. And so suddenly where there was a full forest, now they are cut right down the middle. So what is happening at the edge of that forest where it has been cut versus what is happening in the rest of the forest in the interior pollution-wise? We generally know that edges of forests are going to be more exposed to pollution, but we don't know how that affects the growth of the forest. So maybe you are inhibiting growth if you have more pollutants exposed, if the trees are more exposed to pollutants. But you also could be contributing to growth if it's adding more nutrients. So we're looking at those productivity-wise. And now I am bringing in a component of looking at damage. So if these leaves and these trees are exposed to pollution, is that directly harming the trees? Is that directly prohibiting growth in some way, decreasing productivity through photosynthesis or through any sort of gas exchange? So on the left side here in this photo, you can see some of our samplers placed at the edge of a forest. And on the left side here is just a little cup, but inside that cup is a passive sampler, which means it doesn't actively pull in air, but it passively sits and gases flow through it. And that sampler is used for nitrogen oxides and for ozone. So on one side of the sampler, we are sampling for nitrogen oxides or NOx. And on one side of the sampler, we are testing for ozone concentration. So what happens is we take those little samplers back into the lab, conduct some analyses where we extract the little pads on the samplers, and then we can get an idea for how much ozone and NOx occurred at the edge of the forest versus how much ozone and NOx occurred at the interior of the forest. We also have this sampler right here, which looks very basic because it is. It's just a funnel, and inside that funnel is resin, and that resin extracts nutrients and pollutants from rain. So as rain falls down into that funnel, those resin beads extract anything that is in the rain, so it can just leach those right out of the rain. And we actually extract those resin beads for nitrogen. So we do an analysis for ammonium in the rain, and we do an analysis for nitrate in the rain, and then we do total overall inorganic nitrogen. We also place those at the edge and at the interior, so we can understand how much nitrogen the edge of the forest is exposed to versus how much nitrogen the interior intact part of the forest is exposed to. The implications of these particular pollutants are that in the case of nitrogen, nitrogen can act as a nutrient. So it is possible that if we have more nitrogen deposition falling from the atmosphere at the edge of our forest, we might actually see increased growth of the trees at the forest edge compared to the forest interior. That has a lot of implications both for environmental and human health. I'm also recently this year started sampling for particulate matter. In the same concept of placing the particulate samplers at the edge of the forest and at the interior of the forest. And this is also a passive sampler similar to this ozone and NOx one. But this little tiny stub right in here sits there, and particles will flow through these two plates and land right on that sampler. I then take that sampler and insert it into a scanning electron microscope where it can get really magnified, and we can count the number of particles on there in different sizes, and we can also speciate those particles, which means we can get the elemental composition of those particles to understand what these trees are actually being exposed to elemental wise. To connect that to what the trees are experiencing. So these samplers really just give us an idea of what is in the atmosphere particle-wise. I'm also removing leaves from trees at the edge and the interior and doing a rinse on the leaves to understand how much particulate matter is on the leaves at the edge versus the interior. You can see here a little bit that there's a road here. Some of my forests are against roads as opposed to against open fields like this one. So we're also seeing if there's a difference between what trees are exposed to at the edge of roads versus what they're exposed to against fields. And then there's also an urbanization component. So a lot of my forests are in the urban Boston area, and a lot of them are in rural Massachusetts, in the middle of Massachusetts, out in Harvard Forest. So we're getting a lot of different measurements and a lot of different factors to try to understand how these trees are removing pollution from the atmosphere and also what they're exposed to. So I'm also taking leaves from those trees and putting them under the scanning electron microscope. I'll show you some photos in a second, and investigating them for damage due to pollution. In terms of the health of the trees, so yes, we know that trees remove pollution from the atmosphere. Right now we're quantifying how much, in what way, how does the structure of the forest matter? Is it individual trees or do we need a whole forest? We also know that pollution can damage trees. So you're looking at a photo here of the Arnold Arboretum, which is run by Harvard University, and it's in the center of Boston, one of the most well-known arboretums in the US, especially due to their diversity of species. And it's also where I have one of my field sites, right along this edge here. You can barely see it, but there is actually a little sampler right here. This is one of those through fall samplers with the funnel and the resin for nitrogen. So this is the edge right along a busy road. And then we also have an interior site where the forest is intact. And if you look at a couple of photos here, leaves can experience damage from pollution in multiple different ways, but I'm particularly focusing on particulate matter in this study. This is a photo from a scanning electron microscope that is looking specifically at damage to the stomata of the leaves. So generally, if you flip a deciduous leaf upside down, you're going to see a lot of stomates underneath there. And particulate matter, like these little pieces here, can clog those stomates. That can cause a decrease in productivity of plants and trees. So I am quantifying how many stomates are clogged due to particulate matter in order to understand how that's going to affect overall productivity of those trees, both at the edge and in the interior. This is also another photo from the scanning electron microscope. These very beautiful spindly things are called trichomes. They can occur on the bottoms or the tops of leaves, depending on the species. But what happens is particulate matter gets caught in these trichomes and embeds in there and actually deforms them. So generally, trichomes are used as a defense mechanism to protect the leaf from damage, but those pieces of particulate matter can actually get embedded in there, deform the trichomes, and make them less efficient to protect the leaf. So we're looking at multiple different types of damage here. So stomata clogging can lead to decreased productivity. Trichome damage can lead to less defense overall. It's also, again, really important to note that in terms of species, different species are damaged by pollution at different rates. What that means is different species of trees have a different density of stomata on them, so maybe more of an opportunity for those stomata to get clogged. Some stomates are bigger than others on different species, so maybe there's less opportunity for them to be fully clogged. And the same with trichomes. Some species have way more than others. Some have them on both the tops and the bottoms of the leaves. So it's really important to think about, okay, which species are going to be the least damaged by pollution. And those are the species that we're trying to target to place in areas that have the most pollution, like urban areas. So this research then is applied to city planning to understand how we can most effectively use trees as air filters. So the goal is to find the right place for a tree canopy. Do we need to place these trees directly against roads for them to be efficient? Or can we place them further away? Do they need to be a full forest, a full intact forest? Or can they be just a fragmented forest? Can it be individual trees in a row, in a line? What is going to be the most efficient way to remove particles and other pollutants from the atmosphere? And again, you see this photo again. Can we place our trees against open fields, or does it have to be in really busy areas of urban communities? Are we going to still see a lot of pollution removal if we have these rural or less polluted places, or is that less effective? And that also applies to pollution removal as well. If you see a lot of pollution in one place, it's possible that these trees are going to be damaged faster than trees like this that are in a rural place or against an open field or something like that. So you have to take into account not only the right location for the trees, but also the right type of tree. It's also important to talk about environmental justice and improving community health with this form of city planning. What you're looking at are two maps of Boston neighborhoods. And I know you're probably not super familiar with Boston neighborhoods, so I'm going to explain. The center of Boston is right here. The airport is over here in East Boston. Same if you're looking at this green map right here. And then it kind of spans out into suburbs over here and over here. On the left side is a map of tree canopy cover. So the darker green areas have more tree canopy cover. It's particularly important to look at like the center area where we have a lot of tree canopy covered here, and then down into here. Some of the most covered areas tree canopy wise. If you look on the right map, It is a map of percent racial or ethnic minority. So the darker red areas have higher percent minority. If you look at where we have the most tree cover, like here in this area and over here, we also have the least ethnic minority makeup. What that implies is that we are prioritizing tree canopy in areas that are mostly white. We have this very low tree density over here, and we have this very high racial and ethnic minority percentage in that same place. What that means in terms of air pollution and trees, I'm going to show you this link of this map that we have created through the urban program. And I'm happy to send this link to anyone who would like to see it. This is a similar map of this is the same map of tree cover here with dark green areas of tree, a lot of tree cover, light green areas, not a lot of tree cover. When I put this filter over top, the dark gray areas are high concentrations of particulate matter, and the light gray areas are low concentrations of particulate matter. So if I bring this around and I'm going to put it right over where we have high tree canopy density, you can see it's mostly light gray. So lots of canopy cover means very little particulate matter. If I move it up here, everything gets dark gray, which means low tree canopy cover is correlated with high concentrations of particulate matter. This map has been transformational for helping people understand the relationship between air pollution, tree cover, and environmental justice in terms of communities that we need to be prioritizing that we are not right now. So recapping everything I've talked about today, I know it wasn't a typical research talk. It was more about my past experiences and my current experiences and my research and the implications. But we know that urban areas are polluted mainly due to human activities. So those pollution sources can be from the transportation sector, factories, even just, road dust being kicked up. And those pollutants can be really harmful for both human health and the environment, which is especially important in urban areas where we have that combination of high human population density and high pollution emissions. We know that trees are natural air filters for pollution. I do want to mention that there are components of trees that will cause them to emit pollutants, especially if you're thinking about pollen, things like that. Yeah, we're going to get a little sneezy. It is important to think for scientists to think about what trees are going to remove the most pollution in different amounts and also emit the least amount of pollution. And it's also really important to think about how different tree species are damaged by pollution at different rates. So if we're going to put a tree near a road, we don't want it to be easily affected by what it's experiencing. So the main overarching goals of this research are to determine which tree species are best in which places in order to decrease pollution, but also emit the smallest amount of pollution. So there's no effects that we aren't taking into account. And also to increase canopy cover to combat environmental injustices that are occurring and improve overall community health, especially in the communities that we are not prioritizing right now. And my computer just froze. Okay, So this is my final slide. This just has a few of the people who have funded my research. So anywhere from NSF to the Arboretum itself. And on the right is my information. So if you want to email me or find me on Twitter or LinkedIn, you can do that as well. I'm going to leave this slide up, but shrink my screen down a little bit. And I really appreciate you all listening to this today. So if you have any questions, I would love to hear them.
All right, thank you, Jenna. I'll give you a quick round of applause. Very powerful story. Dr. Schiappa put a question in the chat. Can you see the chat, Jenna?
I just opened it up. Hi, Dr. Schiappa. Okay, you may have said this and I just missed it, but are the urban areas with highest pollution in less advantaged communities identified as environmental justice areas? Some are. So just in terms of the Boston map, pull this one up and zoom in for you. This area, this Mattapan area, is highly disparaged in terms of income, and it is considered an environmental justice area. It's always prioritized for placing of new development projects, things that we are trying to avoid. It also occurs in these other areas along the coast as well. I just don't have the map for those right now. But yes, so the short answer is yes, but not enough.
So,
Are there any questions from the audience? Anyone out there have a question? Lang Smith would like to ask a question. What do you got, Lang?
Hi, Jenna.
He
Hi.
says hello.
So I'm curious, the areas with the high number of minority and low-income populations, how suitable are they for a big urban tree project to, increase the vegetation in these areas?
Were you able to hear that, Jenna, or would you like me to repeat?
No, yeah, I was able to hear it. And that's a great question, and also a question that I've been asking in my research. So there is a community organization in Boston called Speak for the Trees, which comes straight from the Lorax. And they are working in they do work around Boston, but they're particularly trying to target these areas in terms of their tree giveaways and tree plantings. They're not so much focusing right now on the right tree, which is okay. I have opinions, but right now they are trying to target these areas and giving out free trees to the community. Right now, they are just having this community plant in their yards or in spaces that are allowed to be planted, but we plan to work together to work with these communities and determine what the communities want in terms of increasing tree canopy and assessing where we can increase that tree canopy. So there's a lot of impervious surface area in those locations. That's just what we see. So where can we feasibly plant these trees in those areas is the main question. And also, what does the community want? Because the community might not even want us entering their homes or their yard space. So there is a potential to increase canopy, and I do plan to work with Speak for the Trees to do that. But it's fully dependent on the community and what they want to see.
Thanks.
Very good, thank you. There was a colloquium earlier this summer addressing environmental injustices in the Pittsburgh metropolitan area. And a couple of the takeaways from that I recall was down in the Mon Valley, south of downtown Pittsburgh, there's been a lot of chronic air pollution through the years. There's a big coke works down there, and similarly not far away, the large Shell cracker plant is under construction, and we're anticipating tremendous VOC loading, volatile organic compounds. And in those communities, their youth have high incidence of asthma, well above the national norms. And a concomitant outcome of that is that they have a lot of absenteeism in primary and secondary school. And then absenteeism correlates with difficulty with law and difficulty in holding a job. And so there's a propagation of air quality affecting the incarceration rates of people in those neighborhoods. So I just wanted to make you aware that there's that interesting story that's unfolding down in the Pittsburgh region as well. One other thing I want to add, and I'll put it into the chat group, is that this afternoon in my hydro class, the students will be taking their first quiz on a title called Water, A Natural History. And it is written by a woman named Alice Outwater. And interestingly, early in her career, she was in Boston and she worked with water treatment, and she studied the sludge coming out of the water treatment plants. Her story is very compelling. It's one of the most interesting reads in environmental science that I can recall offhand quickly. And I'm just struck by your presence in Boston, and you're interested in ecological linkages, and so was she. So I would encourage you, caution you though, I know you have homework to do, all right, in that Ph.D. program, but this is one of those books that when you pick it up, it's really hard to put down. The chapters are fascinating, and they're kind of very disparate in the beginning, and then they build together into this phenomenal, what I consider some of the most provocative hypotheses in environmental science that I've ever read. So I think that it's a fun opportunity for you to become a bit more versed in some of the ecological linkages that exist right in your backyard there in Boston. So I'll give you the chance to ask any more questions or make any concluding comments. Anything else on your mind, Jenna?
Looks like Dr. Hartman raised her hand.
Yeah, I have a question. So thank you, Jenna, for giving a talk today to us. That was great. And it's also great to see where you got in such a short period of time. This is great. So my question is, are you going to look at the trees, or are you going to do some environmental modeling to basically get from the tree into the area?
In terms of like leaf versus tree area, or looking at ambient pollution versus what's on the tree?
So looking at where to best place the tree. So
okay.
Yeah, so that was the question. So where to best place the tree to decrease pollution?
Yeah.
So are you going to do some environmental modeling, or are you really focusing on each tree? So that maybe that's better worded now.
Yeah. Okay. Yes. Thank you. Yes. So I'm doing right now is just leaf level scaled up to the tree scale. We can also scale to the forest level using leaf area index. So we can work on that, where we plan to scale up to the forest area. The only modeling I'm doing at the moment is working with some people in the environmental health department, and we're looking at how tree placement, depending on if it's in front of your house or a row of trees, an individual tree, something like that, affects indoor air quality in terms of asthma prevalence. So we're combining the environmental health and the environmental science and the biology of tree components to understand that, and we're working with a model to do that. So I think And I hope that study is kind of the, it kind of initiates a greater understanding of air pollution in general in terms of how we place trees. And if we are able to model that study, we can then work on modeling other studies of, okay, if we place trees in a circle around a intersection, how is that going to be different than placing them in straight lines or just one or two trees? So I'm hoping that's kind of going to be the model that starts that.
Okay, yeah, I was also thinking about the way it changes wind direction depending on where you place them, but also the wind direction affects how the trees work as a filter. So it's in both ways. It's not easy to model, but I think I think that's a nice challenge in a way.
Yes. So there's like one main study that has done a modeling that took on this modeling challenge with a wind tunnel experiment where they like placed the tree in a wind tunnel and sprayed particles at it to see what happens with the particles, how do they disperse. And that's been basically the only study on how they're dispersing in the tree canopy that's come out. Because I think if you were to do it in the field, it would be incredibly difficult, but I would love to do that. Like, I would love to like find a tree and spray particles at it and see where they go, because I think that would be really important to know, because you're right. Yeah. So they're maybe going to come from the bottom of the tree. They're going to deposit down from the top, from the sides, and maybe it's possible that the turbulence created in that canopy is just going to whip those particles around and send them right out. So that definitely needs to be researched more. So I think if we place, like, the placement of trees is really important in that case, because maybe if they are sent out of the canopy, maybe they'll just end up landing on another canopy. So hopefully we can get those questions answered in the future.
Thank you, Jenna. Thank you. And good luck.
Thank you.
Oh, I'm muted. Thank you very much. All right, so I was speaking to the microphone, but muted. And I just want to echo Dr. Hartman's congratulations on your accomplishments and our wish for great good luck and a wonderful fall. All righty, finish that Ph.D. Way to be.
Thank you. I'm doing my best. Thanks, everyone. It was good to see you.